Right, we're now going to look at question 2 from the consolidation again. Please just listen to me. If there's something that you don't understand, go back, listen to it again, make sure that you do understand it. Okay, the question says to us, if the sine of theta is equal to negative k, and they tell us that the cos of theta must be greater than naught, and they told me that k must be greater than naught, i.e. those are the restrictions that they've given to k. Now, as soon as I see a question like this, I think to myself, hang on, what is sine? Okay, sine is a trig ratio. What does the word ratio mean? It comes from rational. What does rational mean? It comes from a fraction. So the only way that I can make this into a fraction is if I go and I put it over 1. Okay, now I have two sides in a right angle triangle. Again, sine opposite of hypotenuse, or y over r. Okay, now I've got to decide which quad I'm going to do this in. All right, so sine must be negative. So I'm just going to do a little quad thing over here. Sine is negative in third and fourth. Cos must be positive, so it must be there. So now when I draw my little picture, I know that this triangle is going to be in the fourth quadrant. And I'm going to put in theta, and I'm going to put in that sine of theta is minus k over 1. Okay. Remember, I've now got a right angle triangle, so I can use Pythagoras. And if I use Pythagoras, this will become 1 plus k squared, all square rooted. We leave it like that. We don't try and simplify it. It will not simplify. Once I have all three sides, okay, I can answer any question in the world. So the first question says to me 2.1.1. It says find out what the cos of theta is equal to. So I go into my little triangle, and I know cos is equal to x over r, or adjacent over hypotenuse. So I know it's going to be 1 plus k squared over 1. Obviously, I don't have to put the 1 in. 2.1.2 wants to know what the tan squared of theta is. Okay, now that just means what is the tan of theta squared. It's just another way of writing that out. So tan I know is equal to opposite over adjacent, or y over x. So it's going to be minus k over the square root of 1 plus k squared, all squared, which is equal to k squared, and at the bottom the square root is going to fall away. 2.1.3 says to me they want to know what the sine of theta minus 90 is. All right, so here I'm going to have to think. Okay. Usually if I get ones like this, I always say add 360 to it until it becomes something you recognize. But if I add 360 to this, I'm going to get to 270, which is not going to help me. So I'm going to use a little picture. Right, and I'm going to say to myself, right, I know that theta is in the first quad. If I'm minus 90 from it, okay, if I'm minus 90 from it, I know I'm going to end up in the fourth quad. What do I know about sine in the fourth quad? It's going to become negative sine of theta. And therefore my answer will be negative k, which will give me an answer of k. Okay. Right. Let's go on to question 2.2. Question 2.2, they ask us to find out the answers between negative 90 and 360, okay? And they give me a trig equation. They say 3 times the sine of theta plus 30 degrees plus 1 is equal to 0. Right, so what we always want to do with the trig equation is we want to isolate the ratio. So we're going to say the sine of theta plus 30 degrees is equal to -1 divided by 3. Now, there are different ways that different teachers teach this, okay? So you just make sure that you understand your way. What I do is I use QRA. So the negative tells me which quads I'm going to be in. Where is sign negative? Sign is negative in quadrant 3 and quadrant 4. Then I need to get my reference angle. Okay, how do I get my reference angle? I ignore the sign. Okay, so forget that it's a negative. I go shift sign of a third, so sign to the -1 of a third, and that will give me a reference angle of 19,47 degrees. So now I've done my Q and I've done my R. Now I've got to build what's called my arguments. Okay, now my arguments are going to be, if it was in quadrant 1, it would be my reference angle plus 360k, where k is an element of integers. If it was sine and cos, if it was tan, it would be 180. In quadrant 2, it will be 180 degrees minus my reference angle plus 360k, where k is an element of integers. Again, if it was tan, it would be 180. In quadrant 3, it's going to be 180 degrees plus my reference angle plus 360 degrees again. And in quadrant 4, it's going to be 360 degrees minus my reference angle plus 360 degrees, or 180 if it's tan. So here, I know I'm working in quadrant 3 and quadrant 4. So I'm going to say, right, in quadrant 3, theta plus 30 degrees must be equal to, because it's in quad 3, it's going to be 180 degrees plus my reference angle plus my 360k, where k is an element of integers. Okay, if I use my calculator now, and I go 180 plus 19,47 minus the 30 degrees, I get 169,47 degrees plus 360k, where k is an element of integers. All right, that there is the general solution. It's not the solution they want, but it's the general solution. In quadrant 4, I'm going to say theta plus 30 degrees is equal to 360 degrees, hang on, minus 19,47 degrees plus 360k, where k is an element of integers. Again, if I use my calculator and I go 360 minus 19,47 minus 30 degrees, I will end up with 310 degrees, 53 degrees, plus 360k, where k is an element of integers. Now those are the general solutions, but the question didn't ask that. It wanted to know all the answers between minus 90 and 360. So I'm therefore going to say, right, I start with my first one, 169,47 degrees. If I take my calculator and I add 360, to that you agree that it's too big. If I take my calculator and I subtract 360 degrees, it's too small. It's smaller than minus 90. So that's the only one that's going to work there. I go to the next one, which is 310,53 degrees. If I add 360, it's too big. But if I minus 360, I get to minus 49,47 degrees, which does fit within the range they have given me. All right, that is question 2.